Please title these notes Geometric Applications for Notes Average Value. By the end of this lesson, you should be able to find the average value of a function. So let's go ahead and write down this. We're going to find the average value of f of x from a to b, and this is f of x. We're starting at a and we're ending at b. And so what we're going to do is we're going to imagine taking this curve and smoothing it out until the height of every single point from a to b is the average value. So some of these are going to come down, some of these are going to come up, but we're going to fill in until we have a nice flat curve that's right equal to the average value. So let's see this. That's probably going to be somewhere right about there. So what we did is we imagined smoothing out f of x until the height of every point is the average value. So that means that this height right here is average value. Average value of f of x. And this right here, this is the width of the rectangle. And the width of the rectangle is just the distance from a to b. So it's just whatever value we have over here, b minus a. And then up here we obviously have the area of the rectangle. Now it turns out, because we made some of these shorter, some of these higher, and we sort of smoothed it out, this area right here is the exact same as this area right here. And if we know the area of a rectangle, we know that width times height gives us that area. Here, we've got average value for the height. Width is b minus a. So, if we want to say that we're just trying to find average value, that means that average value is the area under f of x divided by this b minus a. And we know how to find the area under f of x of this rectangle. It's exactly the same as this one up here. It's just the integral from a to b of f of x. And I'm going to write this in what's the standard notation. So this is in the denominator, so I'm just going to let that be 1 over b minus a. So this is the width of this rectangle. And then times the area under f of x, which we know is just the integral from a to b of f of x dx. So this is a really key formula to know. There are a bunch of questions that are really super easy if you know this formula and extremely difficult if you don't. So this is something to just Commit to memory, sleep with under your pillow, make sure that you know it. So let's look at some problems. These are all no calculator. Let's find the average value of y equals 3x squared on the interval from -2 to 2. So we know that the average value right here, it's going to be the distance from -2 to 2, so we just find that by doing 2 minus -2. And then the area under the curve, we're going from -2 to 2, and then this is our function right here, 3x squared. I said no calculator, so let's work that one out by hand. 2 minus -2 is 4. Add 1 to the exponent, divide by the new exponent. We're going from -2 to 2. That cancels out. So we're doing 2 cubed minus -2 cubed. 2 cubed is 8, minus -2 cubed is -8. So this is 16 divided by 4, or 4. There we go. That's all there is to it. Let's do a couple more problems, and that'll be it for the notes. How about we find the average value of y equals x squared over the square root of x cubed plus 1 on the interval 0 to 2. We know average value is the width, so the distance from 0 to 2, which is just 2 minus 0. And then we're going to be going from 0 to 2. We're going to take the area under the curve of this, so that's from x squared, x cubed plus 1, dx. Now, we'll have to do this by hand, so we have to figure out how to take this integral. Notice that we've got something here, x cubed plus 1, that if we take the derivative of it, is going to cancel out with this x squared right here. So that means we should let our x cubed plus 1 be equal to u. du dx equals 3x squared, du over 3x squared equals dx. We're also going to need to convert our bounds. Here, when x is 2, u of 2 is 2 cubed plus 1, or 9. U of 0 is 0 cubed plus 1, or 1. So our average value over here is going to equal 1 over 2, the integral from 1 to 9 of x squared over the square root of u, du over 3x squared. Our x squareds cancel out. We can bring that 3 out over here, so 1/2 times 1/3 is 1/6. And then we're taking the integral from 1 to 9 of 1 over the square root of u, so we can rewrite that as u to the negative 1/2 du. When we take the antiderivative, we're going to add 1, so negative 1/2 plus 1 is positive 1/2, so that's u to the 1/2. Divide by the new exponent. We're going from 1 to 9. Dividing by 1/2 is the same as multiplying by 2. And u to the 1/2 is the same thing as the square root of u, which is going to be useful when we plug our numbers in. Okay, so that's 1/6. 2 root 9 minus 2 root 1. That's 1/6 times 2 times 3 minus 2 times 1. That's 1/6 times 6 minus 2, or 4. And that's going to reduce to 2/3. There we go. Let's do one final one with trigonometry, and then we'll be done. Okay, find the average value of sine x on the interval negative pi over 2, comma, pi over 2. So, average value, we're going to do the width, so from negative pi over 2 to pi over 2 is 1 over pi over 2 minus negative pi over 2. And then we're finding the area under the curve, so that's from negative pi over 2 to positive pi over 2 of sine x dx. Let's simplify this. We have 1 over pi over 2 plus pi over 2, so that's 2 pi over 2, or just pi. And then here we're going to take the antiderivative of sine, so that's negative cosine of x. There's no need to do any u substitution here because we can take the antiderivative of sine x just like it is. We're going from negative pi over 2 to pi over 2. So let's go ahead and draw our axes, figure out what that is. Cosine is the x-coordinate, so this at pi, when x is pi over 2, our coordinates are 0, 1. When x is negative pi over 2, our coordinates are 0, negative 1. Cosine is the x value, so that means that cosine of pi over 2 is 0, and cosine of negative pi over 2 is also 0. Ooh, that's going to be really convenient. So we've got negative cosine of pi over 2 minus negative cosine of negative pi over 2. A lot of negatives in there to make sure you don't lose them. So we've got 1 over pi. Cosine of pi over 2 is 0. We're going to subtract a negative cosine of negative pi over 2, which is also 0. So negative 0 plus 0 is still 0. Anything times 0, good old 0. And there we go. This concludes geometric applications for notes.